All right, now we're going to do the last part of section 13.5, which deals with the law of sines and the ambiguous case SSA. Now, how do you remember which case is the ambiguous one? Well, SSA is that really naughty word spelled backwards. And since it's a really naughty word, that means this is a naughty case. That means this one is not going to be clean and nice. Well, on the screen that you see, here's what you need to write down. When you use the law of sines to solve a triangle for which you know side-side angle, that really naughty word spelled backwards, either 0, 1, or 2 triangles are possible. Very ugly case. 0, 1, or 2. And that's what you've got to figure out when you solve these problems is how many triangles are possible. For this reason, SSA is called the ambiguous case and is a lot more difficult. Copy that down. Now, you're going to need to pause the video, and I'm going to have to explain this chart to you because there are 6 different cases when you are told or given SSA. So you must assume you're given side length A, side length B, and the measure opposite side A, or you know the measure of angle A. Now, if that's the case, step number 1 is to determine, is angle A acute or is angle A right or obtuse? Now, let's start with right or obtuse because those are the easier situations. Now, what you see here is a triangle which I've drawn in blue, and let's say that side A is hinged right here where I'm drawing this big red dot. It's a hinge. It's connected there to side B. If you notice, what I have drawn is a little arrow that shows how angle or that hinge side can swing. Obviously, that hinge side will never touch this bottom line of the triangle, which is blue. Therefore, if side A is less than or equal to B and angle A is either right or obtuse, no triangle is possible. You are done with the problem. You can't go any further. Now, what if angle A is obtuse, like on the bottom picture? Well, if angle A is obtuse and side A is greater than B, side A is greater than B, then it will make a triangle because since side A is longer and it's hinged right there, it will touch that blue line right down there. And here's my arrow to show how that side swings again. Therefore, you got one triangle is possible if this is the situation. All right, now let's go to the more complicated case. What if angle A is acute? Well, then there are 4 different situations, which is what you see in the picture. If angle A is acute, then what we need to do is compare side A to the height of the triangle. We need to compare those 2 sides. So in my first picture, right here where I'm putting the black star, angle A is acute if little a is smaller than h. If A is smaller than H, it will act like this, and it will swing back and forth. It's still hinged right there, and obviously it will never touch the bottom side of the triangle, the blue line. Therefore, no triangle is possible in this situation. What if A equals H? Well, in that case, side A is the exact same length as H. Therefore, it will touch and make a right angle right there. Therefore, one triangle is possible. What if A is bigger than H but less than B? This is the really challenging case because here's side H of the triangle. There's the height. Now, if A is bigger than H, it's got to either touch down here or it's got to touch right here. In that case, there are 2 triangles that are possible. The triangle that is outlined in green, which I'm going to do right here, you could have this triangle which is outlined in green, Or you can have the inside triangle, which I'm outlining right now in red. So there are two triangles that are possible in that case. And the last case is, what if A is greater than or equal to B? Then obviously it's greater than H2. Therefore, you only have one triangle because A has got to be longer than both H and B, and therefore when that side swings, it will only touch in one spot right there. Please pause the video if you need to and make sure your drawings are accurate and labeled. All right, now let's apply that information and let's solve the triangle. You are told that measure of angle A is 60 degrees, and side A, which is opposite it, is 9, and B is 10. You are told side angle. Oops, sorry, I wrote that the bad way. Sorry, I should have it the other way around. But anyhow, step number 1, what type of triangle is A? If I go back a slide, first step, is A acute or is it right or obtuse? Because that tells you which situation you're in. Well, obviously, angle A is 60 degrees, so it is acute. Which means, if I go back a slide, we are dealing with one of these four situations right there. Now we got to figure out which situation you're in. So therefore, let's draw the triangle with what we know. Here is angle A, which is going to be 60 degrees. Let's label that A. Side B, which would be right here. Right here. Side B is 10. And now we got to figure out how long side A is. It's hinged right there, but I don't know if it's going to be able to touch my bottom blue line or not. So what I got to do is I got to figure out the height. Now we know A is 9. It's less than B, but how does that compare to H? Okay, so there's my triangle. Now we got to compare A to H. So we got to figure out H. Well, my big, fat, juicy, black, hairy bug is standing at the 60-degree angle right there. Standing right there. So therefore, we're going to write the sine of 60 degrees over 1 is equal to H over 10. If you solve that, you're going to find out that H is approximately 8.66. Oops. Got to rewrite that. 8.66. Well, therefore, what do we have? Well, A is 9, so that means H is the smallest. A is bigger than H, but A is less than B, which is 10. Because H is 8.66, A is 9, and B is 10. Well, if we go back a slide, that means we're in this case right here. We have two triangles that we have to solve. All right. Well, there are two triangles that are possible. So we're going to have to draw both of them. Well, here's the first triangle. This is the one where side A swings over here. Side A is 9, side B is 10, and angle A is 60 degrees. So then this would be angle B right here, and this would be angle C and side C right there. The other triangle would be the obtuse one that looks like this. All right, so what that means is now again, side B is 10, angle A is 60 degrees, which is right there. This is angle C, this is little c, and this would be angle B, and side A, which is the red line, that would be 9. All right. Well, what do we need to do? People, you will not be able to do this one first because this is an obtuse angle. You must use the law of sines and start with the acute triangle and find angle B. You got to do that first. It's a must, otherwise it won't work out. So therefore, I have the sine of 60 degrees, the sine of A over little a, equals the sine of angle B over 10. Now, if you cross multiply and divide, what you're going to come up with is you will find out that the sine of B is equal to, I got to work this out on my calculator here quick for you, so that would be 10 times sine of 60 degrees divided by 9. And what you're going to get is you're going to get an answer of the sine of B is 0.9622. So what I need to do now is I got to do sine inverse of that to figure out the missing angle measure. Just like I taught you in class, sine inverse of both sides. I'm going to rewrite that again for you. Sine inverse of 0.9622. And if you actually do sine inverse of 0.9622 on your calculator, you'll find out that angle B is about 74.2 degrees. All right, so I know angle B in the acute triangle. Now I'm going to go back over here because in order to find angle B, which is the obtuse one, what that's going to be is the obtuse angle is going to be over here 180 minus this angle that you figured out right here, 74.2. So in our obtuse triangle, angle B is going to be 105.8 degrees. You got to solve both triangles, so therefore that's angle B in my acute one. And if you double check that on your calculator, if you do the sine of 105.8 degrees, you'll notice you get 0.9622. So that's how it works out. All right, well, now we can figure out the angle C is in both triangles. Angle C is going to be 180 minus those two, which is 45.8 degrees. And over here, angle C is going to come out to be 14.2 degrees. All right, so all that's left then is to find side C in both triangles. I'm going to draw this line down the middle. Now, if I'm going to find side C, what I need to do, side C is going to be the sine of 45.8 over C, which is equal to, and I can use angle A, which would be sine 60 divided by 9. And if you cross multiply and divide and figure out C here, you'll find out C is 7.5. And we have solved the small triangle. Now over here, we got to do the same thing and figure out side C. We need to figure out what C equals in the obtuse triangle. So again, we're going to use the information for angle A and side A, which is going to be the sine of 14.2 over C. Again, you use the law of sines, and you get 2.54 if you solve that equation. And that's how you do this. Now you have two triangles. One is acute, one is obtuse, and you've solved both information. So if I go back a slide, if you are told the measure of angle A is 60, side A is 9, and side B is 10, there are two possible triangles, and you have now figured them out. This is situation number 1 over here, and this is situation number 2 over here. If you have further questions, let's discuss it in class, but that's how you do the ambiguous case and the law of sines.